All righty. Let's do this. So, for the majority of you, for the majority of you, you took the test yesterday. I think we only had 1 or 2 people that were absent, so that was good. We'll probably get those corrected this weekend, put in the grade book at some point in time. Yeah, that's kind of where we're at now with this new fandangled grade book and Canvas and all that fun stuff. So we'll get them in there as quick as we can. Okay? So we're back into 4-1 and looking forward now. We'll be dealing with 4-1 today, all next week, and then we will test on 4-1 on the 25th of September. So that's 2 weeks from yesterday. We'll have another summative test in there. Okay? Okay. So we talked a little bit on Wednesday about that there was 2 pi radians in a circle, which also means 360 degrees. Okay? Today our focus is we're going to be converting from degrees to radians and radians to degrees. Okay? And then we're also going to add in some special degree measures too for you when we get later on. Okay? So if we think about this, okay, so if I think about, okay, so that's going to be, this is a known fact. There's 360 degrees in a circle. There's 2 pi radians in a circle. So that means that if I am going to be converting, that's a bad E. If I am converting 2 degrees, then I would multiply by 360 degrees over 2 pi radians. Okay? Because that fraction is equal to what? It's equal to what? It's equal to 1. Because it's the same thing. 360 degrees is the same thing as 2 pi radians, so that means that that fraction is equal to 1. Okay? Or, if I didn't want such big numbers, I could do 180 degrees over pi radians. That's a bad R. Come on, Lance. Be better. Okay. If I'm converting to radians, then I would want my radians on top. So it would be 2 pi radians over 360 degrees, or pi radians over 180 degrees. Again, that fraction is equal to 1. And the reason that we're going to do that is because we've got this, and you've seen this probably in some of your scientific classes. If I want to convert 6 feet into inches, okay, I'm really multiplying by, there are 12 inches in 1 foot. And then my label cancels out, because I've got a foot on the top and a foot on the bottom. Okay? And so then I get my 72 inches there. We'll get more and more into factor label method when we start getting onto the speed chart on Monday, or not Tuesday. Okay? Okay? But for now, let's convert into radians. Okay? Okay? So if we got 90 degrees here, that's what we're starting with, 90 degrees. I'm in degrees, I want to go 2 radians. I'm going to multiply by pi radians over 180 degrees. And then my degree cancels out my degree. Okay? Now, here is where good thing it's a Friday. Okay? Because it's one of those F-word Fridays. Okay? You want to leave your answers in what form? Remember, it's F-word Friday. Fraction form. Okay? All right? Now, you may be using another F word before fractions, okay? But you're going to need to embrace fractions this year because we want all of our answers to be exact. Okay? All right? So really embrace the fractions. Okay? So again, I was just talking about this in the resource center. Okay? So now you can either multiply across first, because remember then that this is technically over 1, and multiply across first and then reduce, or you could reduce and then multiply across. Okay? Either way here, you are going to get pi over 2 radians. Okay? Now, as we develop more and more and more into the radian, anytime that we see pi in our fraction, we're going to assume that we're talking about radians, unless otherwise noted. Okay? With me? What's up?
Yeah, why do you put the radians like actually spelling it out, or why can't you just put it at the top?
You mean this one?
Yeah. I don't know if it was like.
No. That one?
Yeah.
Yep, by all means. Same thing. Okay. Do 210. We'll skip the middle one. We'll do 210 next. So you try right now converting 210 degrees into radians. Should get 7 pi over 6 radians. Okay? Good? We want to reduce all the way down. Okay? Love it. All right, let's go the other way. Now, let's convert radians into degrees. Okay? So now I'm starting with a radian measure, which was pi over 6. That's a radian measure. Now I'm going to multiply it by 180 degrees over pi radians, because now my radians are going to cancel each other out, and that leaves me with just degrees as my only label. My pi's also cancel out. Okay? And so then that leaves me with 6 goes into 180 30 times. Okay? You try 9 pi over 2. How many degrees is 9 pi over 2? I get 810 degrees. Agree? Love it. Okay? We'll do one of these. Let's do 3. What's up?
Does it matter when you convert to radians if you do 2 pi or just pi?
It doesn't matter if you use 2 pi, then you got to use 360 degrees. Yep, doesn't matter. Okay? But with that one, we'll automatically, if you use 2 pi and 360, automatically you're going to have to reduce it at some point. Yep.
Is there situations like that you have to use 360?
Nope. Okay. Nope. Nope, not at all. Okay. So if I got 3 radians, I'm going to do that exactly the same way. I'm not going to change my method one bit. I'm just going to say that that's 180 degrees over pi radians. Now the only thing is that radians is the only thing that cancels out there. So I'm left with the answer of 540 divided by pi degrees. Yes, it looks uglier, but you don't want to actually convert that, do that on your calculator, and get 171.887 degrees, because then that's rounded. This is exact. We can use that if we had to type that into a equation of some sort. We could store it. We learned how to store variables on the calculators before, so we can leave it as just that. Okay? Questions, comments, concerns, clarifications? Okay? Love it. Let's go on. So, as I said before, there are some additional degree measures. Now, why didn't this not? Oh, my Lanta again, failing you even more. We'll just get rid of it. Oh, that's why. That's why it's all the way down there. So then, I know this for those of you joining us on the line, this is riveting onlineness right now. All right, here we go. So 1 degree is 1/360th of a circle. Okay? So 1 degree, so remember, if I'm standing at one point, it takes me 360 degrees to get all the way back around to facing the same direction. Okay? 1 degree of that is 1/360th of that spin. With me? Okay? All right? 1 minute is 1/60th of a degree. So we can take that 1 degree and we can break that up into 60 parts. Okay? 1 second is 1/60th of a minute. Okay? So a degree is 1/360th of the whole circle. A minute is 1/60th of that degree. A second is 1/60th of that minute. So in 1 degree, there are 3,600 seconds. Because we can take 1 degree and we can divide it into 60 parts, and we can take each of those 60 parts and divide it into 60 parts. Okay? So there's 3,600 seconds in 1 degree. With me so far? Okay. All right. We call this form, here DMS because it is in that order. It's degrees, then minutes, then seconds. DMS. Okay? We're going to convert now DMS into decimal degrees. Okay? We call decimal degrees double D. So right now, you are going DMS into decimal degrees. Okay? The reason I say that is because on your calculators, Scientific or Inspire, there is a way to do that to check your work. Okay? It's easier on the Scientifics than it is on the graphers, so we just do it longhand on the graphers because it's super easy on that. Okay? So, there are 3 parts. Your first part just stays whatever it is. So whatever your degree is, that stays. Okay? Then you add to that your minutes, but we need to add like terms together, so I need to make that a fraction over 60. Because remember, a degree is a degree, a minute is 1/60th of a degree, so I'd have to take my minutes and divide by 60 to get how many degrees that is. Okay? Then I would have to go to seconds. In this particular case, we don't have seconds, but there we would divide by 3,600 because we need to get it in degree form. Okay? And so that now I can type in my calculator. So now you go 245 and you add to it the fraction 10 over 60 and you put it in decimal degree form. So that is 245.167 degrees. Now, for this, we will always round to 3 decimal places unless we tell you otherwise. Okay? 3 decimal places is thousandths. We will round always to 3 decimal places if we tell you to, unless we otherwise say something. Okay? So, let's try 148 degrees, 16 minutes, and 25 seconds. So that's going to be 148 plus 16 over 60 plus 25 over 3,600. Because I got to get them all in degrees. Okay? So your fraction, or your addition now on your calculator is going to have 3 in them. So we'd have 148 plus 16 over 60 plus 25 over 3,600. I get 148.274 degrees. What did I say? 274. With me so far? Okay. Going the other way now. Now we're going to go from decimal degrees into degrees, minutes, and seconds. Okay. So now, once again, this 345 stays 345. Okay. Then I take 0.12. I take just the decimal and I multiply that by 60. So 0.12 times 60. 7.2? Anybody? Yeah? 7.2? Okay. So then this becomes 7.2 minutes. With me? So this 7 would be 7 minutes. Make my point there. Then I take my 0.2 and I multiply it by 60 and I get 12. 12. So then I would have 12 seconds. So then this number here, we're going to round to the nearest whole number. In this case, it was a whole number. But when we get down to seconds, we can just round that to the nearest whole number. So this then is 12 seconds. So 345.12 degrees is also 345 degrees, 7 minutes, 12 seconds. Okay? You try converting 215.63 degrees. So for sure this is going to be 215 degrees. Then I take 0.63 and I multiply it by 60 and I get 37.8. So then this would be 37 minutes. Then I take the 0.8 and I multiply it by 60 and I believe I get 48 there. So then this would be 48 seconds. Agree with me on that? Yeah? Okay. Oh yeah, we got time for one more. Okay? From yesterday, what was our mathematical relationship betwixt those three?
S equals R times theta.
One radian is equal to the length of one radius on the circle, yes, but it was S equals R theta. What was the one condition that we had to go along with S equals R theta? Which one? S, R, or theta? Theta's got to be in radians. It was a 50-50 yes. Yeah. Actually, it was a 1/3 chance there. Okay? All right? So, if a circle of radius 12 centimeters and the central angle theta intercepts an arc of length 18 centimeters, we want to find the radian and the degree measure of theta. Okay? All right? So, we would use S equals R theta. S, the central angle arc length, is 18. My radius is 12. I don't know what theta is. Quick solve, what am I going to do? Divide both sides by 12. So then left side gives me 3/2 is my radian measure for theta. Do we concur? Okay. Now, that's the radian part. So that's 1/2 of my answer. Now I've got to take 3/2 and multiply it by, because that was radians, so I'm going to multiply that by 180 degrees over pi radians, and that's going to give me what? 270 over pi degrees. Yes? Okay, so that would be my exact agree with me on that? My decimal would be 270 divided by, sure, where's pi on this one? There it is. My decimal degree would be approximately 85.944 degrees. Yes? My DMS would be 85 degrees, and I would subtract off 85, multiply by 60. That would give me 56 minutes, minus 56 times 60, 37.209 seconds. So I'm going to call that 37 seconds. Okay? Now, it didn't specify if it wanted it in decimal degrees or in DMS. So in that particular case, your default is decimal degrees. Okay? Have at it. You can be doing some homework problems in your homework packet. You probably should be able to do at least through number 10 in your homework packet right now. There should be over there. Yes, they're over there.